Welcome. This presentation is focused on the Object Server aspect of the MVX product range. Objects are a means of organizing data and program code so as to implement some form of automated software system. Traditional industrial automation systems typically organize real-time data as points or tags and then follow up with a naming convention to provide a structure. We believe that an object-oriented structure for industrial automation data has significant advantages over tags with naming conventions. This is the basis of the MVX Object Server functionality. The natural focus of the MVX product range is the 3D visualization aspect. It's what people see up front, and it's difficult to appreciate the underlying infrastructure without investigative effort. We want to run through this plumbing or middleware and highlight that it's just as important a functionality area as the shiny 3D visualization functionality. Taking the analogy of a tree, the 3D visualization is the portion we see on the surface. However, the visualization functionality builds on the underlying architecture, the root system. It is this root system and technological plumbing we are covering in this presentation. The MVX product range has been collaboratively built by two companies, Sentient and Torque. Sentient covers sales, support and maintenance of the product range, while Torque focuses on the product development. This is being brought up here primarily because the Torque name is directly related to the MVX Object Server philosophy. The Torque name is an acronym based on transactions, objects, relationships, and queues. These are the software building blocks used in a software development context. There's an element of choosing the words that make the best sounding acronym, but all of these software concepts are important in the software we build. Of these, the relationships concept is the most important, even more so than the object concept. So don't worry if you don't have a software development background and don't appreciate the nuances of an object-oriented approach. The more important concept is the concept of a relationship, and the one that is the most intuitive. The software concept of a relationship is easily understood if you look at equivalent concepts in other areas of our lives and computing. When dealing with the World Wide Web, the relationships are the hypertext links embedded in all of the web pages that link associated pages. When thinking of people, the other people that are known are the relationships or contacts in a business relationship sense. When thinking of social networks, it's the links between the people recorded in the social network. The MVX Object Server allows us to apply the concept of relationships, or links, to industrial automation points and tags. The MVX Object Server functionality has a core value proposition that is based on the power of relationships. The power of relationships can be expressed as this templated statement. Though there is significant value in X, orders of magnitude more value can be achieved by combining X and Y, where Y is some form of relationship. Let's apply the statement to some scenarios and see how it fits. Though there is significant value in web pages, orders of magnitude more value can be achieved by combining web pages and links. Though there is significant value in people's individual knowledge and skill, orders of magnitude more value can be achieved by combining people and who they know and have access to. Though there is significant value in a website knowing who you are, orders of magnitude more value can be achieved by combining website users and who they know. The MVX Object Server applies this relationship value proposition to industrial automation. So restating, though there is significant value in a software system knowing the data points and tags, orders of magnitude more value can be achieved by knowing the relationships between the points and tags. We believe there's a fundamental truth here, and one that hasn't been fully leveraged in industrial automation system data management. Sure, the concepts have been used within the software development of these systems, but not at the data management level, not at the level seen in a day-to-day basis by users of these systems. The power of links and relationships is also illustrated in the building blocks of the matter around us. A wide variety of molecular forms can be built up from a limited set of atomic types by linking these atoms in different ways. This slide was mainly included as it highlights why this particular presentation display style was chosen. Okay, it's understandable if you start questioning the benefit of this high-level concept approach to this presentation. It's possibly way too abstract. However, we think that abstraction has significant benefits as long as it doesn't stop us from implementing software in a timely manner. Just keep these link and relationship concepts in the back of your mind when we start looking at some MVX Object Server functionality. Before we proceed, it's important to note that MVX still supports a traditional tag-based approach to configuring an HMI. We haven't abandoned it in favour of the one true object server way. There is no one true way with any of the software we develop. There are just different approaches that are more or less suitable to a software requirement context. Tag-based configuration is still suitable for smaller systems and where the support and maintenance overhead of changing the HMI for every individual data point change is acceptable. The MVX pipeline demo is one where a tag-based approach has been used in the definition of the 3D user interface. The tag names are directly stored in the 3D editing environment used to define the visuals. So, for larger and more complex systems, we recommend leveraging the MVX Object Server functionality and embedding more smarts in the server software, allowing the client-side user interface software to just define rarely changing scene or large equipment items. We are able to embed an MVX Object Server into any Microsoft.NET program. It can be a background service that has no direct user interface. It can be a .NET program that your developers write, or it can be the default Windows service that comes with MVX. In the example shown here, the MVX Object Server has been embedded into a Windows program that is also an MVX configuration program. Object Server communications are started and stopped using the play and stop buttons at the top of the server window. The client program on the right is displaying a 3D scene. It is being configured so that it knows what a truck and a light looks like in a 3D space. Whenever the server says there's a new piece of equipment, such as a truck, it appears in the scene. A 3D visual template is defined once in the visualization client program and then is automatically reused whenever the server indicates there's a new piece of equipment of that type. We can dynamically change equipment state and terrains such as pits and stockpiles on the server side without the need to alter the 3D scene master files. In this demonstration run-through, we're showing a configuration server. This is a Windows program that is both the user interface for configuring an MVX system and the communication server. It's placed in server mode by clicking the play button in the toolbar. The configuration system includes system settings and user configuration so that different users can access the system with different access levels. The items of equipment in this demo are limited to lights, cameras, scanners, stockpiles and trucks. Additional equipment types can be added for your functionality needs. I've started the server and run the 3D client program. Note that the one truck that has been configured appears automatically. The configuration of this particular type of truck is primarily position and orientation information. If we change the information on the server, it is automatically reflected in the 3D program. This includes information such as its position in space, I'm showing the Z location at the moment. Y is the vertical and Z is, in this case, how far away the truck is from my current viewpoint. We can also change the orientation through roll, pitch and yaw properties. Let's add a light source. This can represent a physical light for night work. The server-side light status changes are automatically transferred to connected clients. In this case, I've been changing the luminosity and whether the light's been switched on or off. I can also change the position of the light. Basically, any equipment attribute can be displayed as a dynamic state in the 3D environment and mastered on the server. Okay, let's move this truck to the side. We can now add multiple trucks through configuration and then position them in the space. This is an illustration that there isn't a need to go back to a 3D designer whenever a configuration change is needed. It can be performed by people comfortable with typical Windows programs. I'll be adding just one more truck as this part of the demonstration. Now typically the large pieces of equipment would be just defined in the scene by the 3D designer. It's not worth making it dynamically changeable, but for more for functionality or system layout that varies often or on a monthly basis, we're suggesting the object server approach. Okay, now we're connecting another client. This client program is called the MetaServer Explorer. It connects to an MVX Object Server and displays the object structure in a hierarchy. It's useful for maintenance and a tool for engineers and developers setting up systems. So here I'll turn on the light, and you can see the light turn on both within the Explorer window and in the 3D space, and we'll change the luminosity, and you can see it changing in both. And there's the 4 trucks that are being configured. So this MetaServer Explorer is connected to the server. It hasn't read the configuration, it's just asked the server what's the current state of the object model. Now it just displays state information, while the 3D program converts that state information into a 3D visualization. The raw object data and structure can also be shown in the 3D visualization program as a general utility option. This just shows the raw object data that is communicated and uses the basis for the dynamic 3D content. It's the same information that MetaServer Explorer displays, but within the 3D environment as a useful utility option. The storage of the objects and their relationships uses the JSON format as the default. JSON stands for JavaScript Object Notation, as it is based on the JavaScript language syntax. It's just a file format and is not tied to JavaScript in any way. The MVX Object Server uses JSON text files by default, and it's anticipated that for even large systems this will be quite satisfactory. We've used it as opposed to something like XML because of the ease of supporting relationships or links between objects. Other database options are available. We've also developed a true object-oriented database backend using the Matisse database, which we've used on other software development projects. Using an object-oriented database is hugely beneficial in reducing the work needed to represent complex relationships. Other databases can be implemented on request, but you would need to anticipate an additional expense in using a traditional RDBMS because of the object relational mapping work needed.